Okay, so on this one, I'm assuming that you read it, and we're going to do what is the probability that step 3 will take less than 6.3 minutes. So this is going to be a z-score. We're just going to use this stuff right here, right there. Okay, so let's set it up. So it is, what is it? The thing we're interested in, which is 6.3 minus what we think it's going to be, 6.6, whoops, 6.6, divided by the standard deviation, which is 0.23. And the answer is negative 1.3. 1.3 standard deviations below. And we're going to say, what's the probability that is less than that? So we are not going to subtract from 1. So normal CDF, negative 1,000. Lower, upper is negative 1.3. And let's see what it is. And we get 0.096. So there's a 9.6% chance. 9.6% chance that this process would take longer than, oh no, less than 6.3 minutes. Let's look at letter B. Okay, what are the mean and standard deviation of the total time? Well, this is the mean of each step, so we just add them together. That's going to be the mean of the total time. So that should be, what is it? It is 27.5. So mean total time. $27.5. Okay, on average, that's how long it should take. But what about the standard deviation? Okay, so remember, we got to square them and add them and take the square root. That's how we get that total time. So for the combining standard deviations, square them, add them together, and take the square root. Works the same if you were subtracting them. You still add them together. But anyway, the answer to that is going to be 0.48 minutes. So that's the standard deviation for the entire process. So about 27.5 minutes, give or take a little less than a minute. That's how long it's going to take. So on this one, we're going to use our new average and our new standard deviation to figure out letter C, which is it going to be more than 29 minutes? Let's see what that looks like. So it's a z-score, and we're going to say the time we're interested in is 29 minutes, and what we think it's going to take is 27.5, and our new standard deviation is going to be 0.48, and it says more than 29 minutes. So we're going to get normal CDF, and this time we're going to subtract it from 1. Okay, so let's see what that looks like. So when you do the math, it's 3.125. That is a lot of standard deviations above the average, so it's going to have a very low probability. Anyway, let's do normal CDF, negative 1,000 is the lower, 3.125 is the upper. Whatever number you get, you subtract from 1, and you should get 0.009. Okay, so you have a 0.9% chance, less than a 1% chance that that's going to happen. Number 6, this is a linear regression problem. Now it's a little bit jacked up because there should be an equal sign there and a plus sign right there. This is the equation of a line. So interpret the slope of this model in context right here. 6.23 is the slope. This is the intercept. So this is our prediction right there, y hat. Now, for our incentive, if you read, they gave them these bonuses. for every cent, every penny that you give these workers, they're going to produce approximately 6.23 more of whatever they're making. Okay, so that's how you interpret the slope of this model. Increase by a penny, you get 6.23 more of that thing that they're making. Use the model 1 to predict the productivity when the incentive is 25 cents. So take this 25 and plug it in right there. 25 times 6.23 plus this number tells you how many things you're going to get made with this 25 cent incentive. So let me figure that out. So I plugged it in, and you should get 15.45, and 47, like that. That's going to be our increase. So if you gave 0 incentive, you would just get this much. But they give a 25 cent incentive, which gains them this much more. Okay, let's take a look at letter C. So again, this is kind of jacked up because this should be y equals, this is what we get, plus this, plus this, plus this right here. So when you are a non-union worker, you end up with this. So in the formula, when you are a non-union worker, they're going to plug in a 1 in here for type. So you get this right here, the incentive, right? And you get this little bonus here because you would put a 1 in there, 1 times that, and 1 times this. So that's for a non-union worker, we get this much, right? Then if you're a union worker, they plug in a 0 here. 0 times this is going to give you 0. 0 times this is going to give you 0. So when you're a union worker, all you get is this. So let's take a look at what that looks like. And I just use the letter I for incentive. So these are the two graphs. So you might graph these two on your graphing calculator and take a look at what's going on. And as you could probably guess, the non-union worker is going to produce more. And then the last one, letter D here, is we're just going to take 25 and plug it in where the I is to figure out the difference between a union worker and a non-union worker. Okay, clear as mud.